So Excel has a selection of functions that you can use for finding values related to the student t-distribution. And if you've already watched the lecture on Excel's normal distribution functions, there's going to be a lot of similarities. All right, so first, if you want to calculate, this is our standard probability, right? Cell A4 here, the probability of getting a result less than a given t-score. The formula is very similar to what we did with a normal distribution. We're going to do equals t for t-distribution dot dist. That's the what we're always going to use with all of these probability distributions when you want to find an actual probability value. And I'm going to give it some values, right? It wants the x value. Let's do negative 0.1. And just picking numbers for an example here, we'll do 10 degrees of freedom. And this cumulative parameter, if you're looking for a probability, it's always going to be true. That tells Excel I want add up all the values below negative 0.1. Now, I've set this up so that Excel is displaying the formulas instead of the results. That's going to kind of keep the formulas in front of us, so you can always see what we're talking about. And we'll switch back and forth, so we will see some of the output in a little bit here. Now, unlike with the normal distribution, the t-distribution actually has a formula that will do a greater than. Remember, with the normal distribution, we actually had to use that rule, that the 1 minus the probability less than. Here, there's a function. It's going to take us right to the answer. I'm going to do t.distribution.rt for right-tailed, right? So instead of giving us to the left of the t-score, that's going to give us the value to the right. And I'm going to say 0.1 here, comma 10, close parentheses. Notice there is no cumulative value here. You only get that one with the less than. And now let's think about what I've asked it for here, right? Remember that the t-distribution is symmetric. So the area below negative 0.1 should be the same as the area above positive 0.1, assuming the degrees of freedom are the same. So I'm going to switch off the formulas here for a second. And you can see, yeah, exactly. We did get the same results both ways. Okay, now that's 2 of 3. There is a third probability function, t.distribution.2t for two-tailed. Right, so what that's going to give us is the area in both tails. It's going to give me, and let's get an example in here, 0.1, comma 10. That's going to give me the area above 0.1 and below negative 0.1. Two tails, right? The upper value and the lower value. Think like what we see when we're talking about confidence intervals and two-tailed hypothesis tests. Now, again, we should be able to just kind of check this, make sure we're interpreting the formula correctly. In rows 4 and 5 here, I already found the area in the two individual tails. So this right-tailed formula, this should be the sum of the values in rows 4 and 5. And if I go back to the results, yeah, you can see that it is. Right? If you add, and we can actually do it to check here real quick. Let me add this and this. And there was some rounding going on there. Let me make it bigger so we can see the detail. And yeah, sure enough, we came out to the same value. Right? Nice little shortcut. Right? So if you're trying to find the two-tailed area, you don't have to find the upper and lower and add them, or find the upper and double it, any of that kind of thing. You can just go straight to the final result. Okay, so those are probabilities. Now let's say you need t-scores, right? You're trying to find, you're doing hypothesis tests, for example, and you're trying to find critical values. Well, we can find t-scores here as well. So let's say t-score. And we're going to do this the same way we found z-scores. Remember to find probabilities. It's t.dist for distribution. And for z-scores, it's going to be t.inv, right? Inverse. So here, if I give it a probability, right? Let's say, let's see, I want to kind of test this, right? So what I'm going to do is I'm going to give it this probability that we calculated up here, and I'm going to give it the same number of degrees of freedom. And now when I go back to the output view, this should give me negative 0.1. Hopefully, yes. And there you go, right? It worked. It is kind of doing what we expected it to do. So just to be clear, right, that gave me the t-score that had an area below that value equal to that value that was up in cell B4. Right, and now when we're doing hypothesis tests, for example, sometimes we need to do two-tailed. Right, we know the area that's in both tails. Well, we can find the corresponding two-tailed t-score. Right, we're going to do t dot inverse dot two-tailed. It's going to ask us the same question. It's going to ask us for probabilities and degrees of freedom. So let's try our test again. Let's give it this probability, and we're going to give it the same degrees of freedom. And let's check the output. Right? See what I got? 0.1, right? Which was exactly the t-score that I put in here. I have trouble highlighting. There we go. That I put in here in the formula, right? So let me go out of there, go back to showing the formulas. So those are our t-distribution functions, right? And just again to kind of summarize, you're going to use this dist to find probabilities, and you're going to use this INV, the INV formulas, to find t-scores.